in this problem, did it say round? So because it did not say round, your answer is going to be 311.2. It did not say round.
So you only partly murdered someone.
Correct. When I first did this one, I was like, I think when I did mine, it was 214.9. So I said 215. It marked it wrong. So I said 214. It marked it wrong. And I'm like, I know what I'm doing. And it made me partly murder somebody. Because I'm like, in real life, you're either murdering them or you're not murdering them. But it didn't say round. So because it didn't say round, they wanted the exact answer. Good? All right. Next one that I was asked to work is the next problem, number 7. .2 number 7. According to an almanac, 60% of adult smokers started smoking before turning 18 years old. Compute the mean and standard deviation of the random variable x. The number of smokers who started before 18 in 300 trials of the probability experiment. Interpret the mean. So this is telling me they want the mean, and this is telling me they want the standard deviation. So, how do you think we're going to find the mean? Do what?
1 Varsat.
Okay. Do we have anything to put in 1 Varsats?
No.
Like what could we, I mean, 60% of 300 people started smoking before they were 18. Yes,
Once you multiply the percent times 300.
exactly what we did last time. So to get my mean, we're going to do 60% of the 300 people. So we can either do 0.60 times 300, or we can do the is over the of equals the percent over the 100. My 60 is my percent, my 300 is my of. I can do it either way. So if I come over here, I can either do 0.60 times 300, or I can do 300 times 60 divided by 100, just to show you they give you the same answer. And that should make sense, y'all. What's half of 300? So 50%, half of it is 300. So 60% should be a little more than half. So mathematically it makes sense. So my mean is going to be 180. Now, standard deviation I have to think about a little bit. Standard deviation, we usually say 1 var stats, or we think about distribution and standard deviation. This is one where we used a formula. And some of you may remember it when I draw it up there. Standard deviation was the square root of NP parentheses 1 minus P. What do you think N's going to be? We only know 2 things. What do you think N's going to be? The 300. What's my P going to be? 0.60. 1 minus 0.60. So it's going to be the square root of 300 times 0.60. 1 minus 0.60. That's going to be my standard deviation. So I'm going to do the square root of 300 times 0.60, and then parentheses times parentheses 1 minus 0.60. So my standard deviation, and they want it to the nearest tenth, is gonna be 8.5. Now, then it says interpret the mean. What does this mean? It says 60% of the 300 people started smoking before they were 18. So it's expected that 50% of the people 180 started smoking. It's expected that a random sample of 180 started smoking before 18. It is expected of 300 people, 180 started smoking after 18. So, of the 300, are we talking about that 180 started smoking after 18? No, this was before 18. So it's between these two. Was it 50%? It was what? 60%. So my answer is going to be B. So here we don't like the word after, and here we don't like the 50%, it should be 60%. James, was there one you wanted me to work?
You already worked it.
Okay. I'm that good.
I have one quick one if you
Okay.
want to do one more.
Absolutely.
It's number 7 on 5.5.
5.5, number 7. Let's see if we know how to do it. That'll be the key. 5.5, number 7. Let's see, 5.5, number 7. Snag it. Copy. Paste. Number 7. Suppose was this one Yoki? Suppose a shipment of 160 electronic components contains 4 defective components. So that means in 160 radios, 4 are broken. Okay? To determine whether the shipment should be accepted, a quality control engineer randomly selects 4 and tests them. If 1 or more is defective, it is rejected. What is the probability that the shipment is rejected? So we did one similar to this. We did, didn't we? Hold on, let me go back and look.
It might have been the number 10 on this one, where it was talking about the students and teachers on the jury.
Okay, so what is the probability? Quality control engineer randomly selects 4 of the components and tests them. So we want to know the probability.
You have to do one get working, then do one minus the other.
Yeah, that's what I was thinking, they're rejected. So I'm going to do the probability that they all work. So if we have 4 that are broken, how many work? Because there's 160 total. Are you with me so far?
Yeah.
4 broken, 156 work, because they give me 100, you're broken or you work. So I want to know the probability that they all work. So it's kind of like the boys and the girls that we just did, or the faculty and the students that we just did. So we have broken and we have work over total, just like we did the faculty and the students. So if they all work, how many are we picking? We're picking 4. So is this a permutation or a combination? This is a combination. So how many broken are we picking? How many broken are you choosing?
Zero.
We want them all to work.
Oh, no.
So we're picking no broken. So we're picking no brokens out of how many that were not broken, that were broken?
56.
Or, what's on
And 4 out of,
it? 156.
and 4 out of,
156.
so you were picking 4 out of the working pile, none out of the broken pile, and 4 out of the total. So you picked 4 from the working crew, 4 from the ones that work, none from the ones that were broken, and so that's 4 from the total crew. Now, when you get your answer, that represents the working. We want the rejected. So let me do the answer to this one first. So it's going to be 4 math probability NCR of 0 times 156 math probability NCR of 4 divided by 160, put parentheses in there just in case, 160 math probability NCR of 4. So that tells me that 0.9, okay, and it's saying 4 places, so I'm going to go ahead and go 4 places. 9028, that represents the working probability. I want to know the rejected probability. So the rejected is going to be 1 minus the working. So if 90% are working, the rest are going to be broken. So it's going to be 1 minus the 0.9028. So I'm going to do 1 minus 0.9028. So that represents the ones that are broken or rejected. There's my answer.
Are you sure?
I think
just
so.
tried so hard on this one and I could not get it.
Yeah, but if you treat it like the faculty and student one, you're picking none of the 4 broken, you're picking 4 of the ones that are working,
Okay.
like we did the faculty and the students,
Right.
and you're picking 4 of the total.
Okay.
But when you get that answer, that represents the ones that are working.
Okay.
But we want to know the rejected, so we do 1 minus.
Got it. Okay.
Anybody else? Now we're ready to start on 7.1. All right, so this is the new material. 7.1, and we're starting off easy, y'all. Ugh. Y'all get this part wrong, I'm gonna beat you. Determine whether the graph can represent a normal curve. Is this a normal curve? No. Tell me what kind of curve it is. Skewed right. Okay. So this one is not normal. I would say it is skewed right. Is number 8 normal? Yes. That one is normal. Is number 9 normal?
No.
No. Tell me why it's not normal.
It's below that.
Correct. This is not normal because of that right there. Is number 10 normal?
I think so. Yeah. It's not normal. It just looks more normal than 10.
Can't flip up. When you draw that normal curve, you want these to like tail off to infinity, kind of taper off to that X line. It doesn't go below the X. It tapers off and gets very, very close. It doesn't flip back up, because if it flips back up, it's going to make another hump. Or it's going to go back up to Never Never Land. So these two little tails right here makes it so that it's not normal. If they would have come down, then it would have been normal. So these little things right here make it so that it's not normal. Had it done that, then it would have been normal. But because it's flipping up, that's what I don't like. Y'all with me? And I know you hadn't seen one like that before. Okay, let's look at a couple more. Oops. What about number 11? Normal or not normal?
Yes.
Yes, that one's normal. What about number 12?
No.
That is not normal, because we only should have one hump there. We don't need a double hump. Okay? All right, so we started off pretty easy. Now, I'm going to show you kind of a problem worked out in the book. It says, refer to example 1, and I've got the figure down here. What is the probability that your friend will be between 10 and 20 minutes late? So, I'm going to show you this problem first down here. What they did is they went from 0 to 30 minutes, and they went in 10-minute increments, okay, and they made a little box. So the probability is a uniform distribution. The probability is going to be the same. So 10, 20, 30, so the amount of time, they divided it up and it became 1 over 30. This number, the amount of spaces, they divided into 30 spaces, that's where that number came from. Now, the question said, what is the probability that the person is between 10 and 20 minutes late? So we're looking for the area of this box. So how do you find area of a box, of a rectangle? The area of a rectangle is length times width. So we need to know the length and we need to know the width. So, how far is it between 10 and 20? 10. And they've already told you that the height from here to here is 1 over 30. So between here and here is 10, and from here to here is 1 over 30. So it's going to be 10 times 1 over 30. And if I need to, I can do that in my calculator. 10 times 1 over 30. And then I'm going to math enter just to make it a fraction. So when the question says, what is the probability that your friend is between 10 and 20 minutes late, it says we want to know the area. The width is 10 and the height is 1 over 30. So we're going to do length times width. So the probability that your friend is between 10 and 20 minutes late is 1/3. So there's a 1/3 chance that they're going to be late. Are we good with that one? Question B. It is 10 a.m. There is a 20% probability that your friend will arrive within the next blank minutes. So this time, they gave us the area. 20% chance. They told us that this was the probability. We know that that's 1 over 30, but we don't know what the time is. We're still going to use the same formula. We're still going to use area equals length times width. The only difference now is they gave us the area. They gave us, quote unquote, the answer. The answer is 0.20. That was our 20%. We do not know the length. What is our width? What is our height?
1 over 30.
1 over 30. That needs to be a times right there. So what do I need to do to get the question mark by itself? The opposite of multiplying by 1 over 30? is dividing by 1/30. So I am going to divide by 1/30 and divide by 1/30. So in my calculator, I'm going to do 0.20 divided by 1/30. So there's a 20% chance that he's going to arrive between 0 and how many minutes? 6 minutes. So sometimes they will give you the minutes or the length, and they'll give you the width. Sometimes they'll give you the width and they'll give you the percentile or the probability, but they won't give you the minutes. But because it's uniform probability, it makes a rectangle. Now, let me give you one. This one says the reaction time X of a certain chemical process follows a uniform probability. Uniform probability, normal distribution would be like that. Uniform probability means that it's going to be like what we just did. The probability is straight across, that's uniform. It is going from 5 to 10. So it starts out at 5, then we go 6, then we go 7, then we go 8, then we go 9, then we go 10. Draw the graph of the density curve. Okay, so we're not starting at 0. We're not going from 0 to 30. We're going from 5 to 10. Now, I need to know, what is this going to be? What is that going to be? 1 over what? Let me come back over here to show you. See how this was 1/30? Because between here and here were 30 slots, 30 pieces. That's why that was 1/30. So, let me show you. So if I do this, that is 30 because there's 30 pieces. So when I come here, I need to know, what is that number going to be up there?
1/5.
1/5. Because there's 1, 2, 3, 4, 5. You can't just take that number. That number would be if it was from 0 to 10. So this is going to be a 5 because there's 5 pieces. Does that make sense? So this is going to be 5 pieces. That's why that's going to be 1/5 up there. Okay? Now, question B says, I think I gave myself room to do these. So for question A, and they kind of drew it out, but I just did by the number of pieces. So for question A, it says draw it out, which is what I just did. We have the 5, 6, 7, 8, 9. And each piece, it's kind of like showing you that there's 5 bars. 1, 2, 3, 4, 5 bars. So each bar represents 1/5. That's going to be my height. We go for part A. Part B, I think I copied it down here. Nope, I didn't. Part B says, what is the probability that the reaction time is between 6 and 8 minutes? So, for part B, we have our 1/5 up here, 5, 6, 7, 8, 9, and 10. We want between 6 and 8 minutes. We're going to do that our area is length times width. We want to know the area of this box. What is the length of that box? How wide is that red box? It is 2. How tall is that box? 1/5. So it is 2 wide, and it is 1/5 tall. So my answer is going to be that it has an area or a probability of 2/5. Yay? Now, if I do the next one, 5, 6, 7, 8. If this is 5, 6, 7, 8, and I want to do the area of that one, how wide is that box? 3. How tall is that box? 1/5. So that would have an area of 3/5. Because for part C, you're going between 5 and 8. So between 5 and 8 is 1, 2, 3 times 1/5. What is the probability that reaction time is less than 6? 5, 6, 7, 8, less than 6. Area equals length times width. What is your length? Times. And I have all of them written out for you. I'll scroll down so that you can see them. Let me uncover. So, for part B, 6 to 8, 6 to 7, 7 to 8 is 2 times 1/5. 5 to 8, 5 to 6, 6 to 7, 7 to 8 would be 3 times 1/5. And less than 6 would just be 5 to 6, which is 1 times 1/5. I could actually... Write these down. Draw a picture of what I need from home. So that you can have it in your notes. 5, 6, 7, 8. So that would be, 6 to 8. That would be 2 times 1/5. And this would be 5, 6, 7. This would be 1/5 times 3. And this would be 6, 7, 8. This would be 1 times 1/5. That way you can see the picture if you need to. We good? All right, now back to some super hard ones, y'all. Determine whether or not the histogram indicates a normal distribution. So, does this histogram show a normal distribution, yes or no?
Yes.
Yes. If I take a highlighter and I connect my dots, that would be a yes. What about the next one?
No.
No. What kind of distribution is that? Right skewed. What about the next one?
No.
No. I would say that one's right skewed as well. What about the next one?
Yes.
Yes. So that's a yes, no, no, yes. Normal, not normal, and normal. And the two in the middle were skewed right. All right. We've talked about mean and standard deviation before. Remember when we were doing normal? If I gave you a normal distribution, I told you that the mean was in the middle and that the standard deviation was the size of the jumps, okay? So for this problem, it says one distribution has a mean of 10 and a standard deviation of 3. The other has a mean of 10 and a standard deviation of 2. Determine which graph is which and explain how you know. So they both have a mean of 10. This one has a mean of 10. This one has a mean of 10. So a mean of 10 and a mean of 10. So that doesn't tell me anything. One has a standard deviation of 3 and one has a standard deviation of 2. Which one is which? Is A the standard deviation of 2, or is B the standard deviation of 2? A is the standard deviation of 2.